In these problems, we're being given a graph of a function and then being asked to match it with a set of information about that function. And they're giving us information such as the zeros of the function, some points of the value of the derivative, where the derivative is greater than 0 or less than 0, and where the second derivative is greater than 0 or less than 0. So let's look at this one. We have a basic parabola. So the zeros of the function here and here looks like -3 and 1, and it looks like that's listed the same in each of these answer choices, so that's not going to help us. And then it says f prime of -1 equals 0, so that's a local min or max. In this case, it's a local min. It's right here where the slope of the tangent line is 0. That's what that means when the derivative is 0. And that's at -1, and that's clearly right, and that's the same on all of these too. So let's move on to the next part. Here we have the first derivative, and it's telling where it's less than 0 and where it's greater than 0. Now, what the first derivative gives us is the slope of the tangent line, so whether the function is decreasing or increasing. You can see this one is decreasing until it gets down to -1, and then from there on out, it's increasing. So A says f prime of x is less than 0 if x is less than -1. Well, that's right, it's decreasing, so the derivative will be less than 0, will be negative, until you get to -1, and then it's greater than 0 or increasing to the right of that. So this works. Let's see, this one's the opposite of that, so B can be out. This one says it's greater than 0 as long as it doesn't equal -1. Well, that's not true, because it's certainly decreasing on the left side of the graph. And this one says it's less than 0 if x is not -1, and it's certainly increasing on the right side of the graph, so that's out. I guess we found our answer, but we should look at this second thing too, just to verify. It says f double prime of x is greater than 0. That's the second derivative, and what the second derivative tells us is concavity. And if this is greater than 0, it's saying it's concave up the whole time. And if you look at the graph, you've got this cup shape and it's pointing up. It's concave up everywhere. So that fits. Let's try another one like this. All right, here we have a typical looking rational function. And I think it's best to make some judgments about the function before we jump into all the notation down here. And what I see is starting over here on the left, it's slowly increasing, and then it increases really, really fast and probably goes up to infinity there at around x equals 5. And then at x equals 5, it starts down at -infinity and increases quickly, and then gradually the curve flattens out and increases more slowly. But it looks like this graph is increasing along its whole length except for the point of discontinuity, which is at x equals 5, when the function goes crazy and is at infinity and -infinity at the same time. So that's a good insight to have before we jump into this. Let's see what these things say down here. So starting with A, we've got f of 3 equals f of 7 equals 0. So those are the zeros of the function. And that looks right. F of 5, or f prime of 5 is undefined. So there's no derivative at x equals 5 because the function is not continuous there, so that looks good. And then it says f prime of x is greater than 0 if x is less than 5, but less than 0 if x is greater than 5. What the first derivative tells us is whether the function is increasing or decreasing. We've said it's increasing along its whole length, so it should be greater than 0. The derivative should always be greater than 0, not less than 0. So that doesn't work. Let's look at B. That first line is the same. Here they're talking about the derivative being less than 0. That's not going to work. This one, the first line is the same. Here the derivative is less than 0 if x does not equal 5. That doesn't work. It's never less than 0. Here we have f of x is greater than 0 if x does not equal 5. That fits. And then f double prime of x, the second derivative, is greater than 0 if x is less than 5. So what that's saying is greater than 0, second derivative, that means concave up. So on this arm of the graph, it's concave up. And that makes sense. We've got this cup shape that's pointing up. The other half of the graph, it's concave down. So let's make sure it says that. F double prime of x is less than 0 if x is greater than 5. So the concavity checks out, and D is our answer. So that's a little bit of work with graphs of functions and interpreting what the first and the second derivatives mean on those graphs. My name is Larry. I'm a teacher at EdVisions Off Campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethischool.org. Thanks.